Yeah, hello. My name is Bruce Slutsky from the Robert Van Houten Library at NJIT. The aim of this lecture is to show you how to find physical and thermodynamic properties of chemical substances. I have done this for students of Math 225 at NJIT, which is a co-requisite to the physical chemistry laboratory, but certainly other students are free to use this. Okay, so there also you can find these from a variety of print and electronic sources. I know in this day and age everybody wants their information online, but there are some times that you do have to use a traditional print source to find the information that you need. Okay, so the physical and thermodynamic properties of substances are valued of chemists all over, that you need the data to identify substances that you synthesize in the laboratory, or you might isolate them from a biological or environmental sample. Okay, and same thing engineers. I know many of the students here are chemical engineering students, and you need to know the properties when you design a plant. There are, of course, many chemical substances. Some of them are chemical elements or very simple chemical substances that are known to laymen. They've been around for hundreds of years, and it's relatively easy to find data on those. But there are also obscure chemical substances, and it might be difficult to find data on those. And there's also a lot of redundancy. You can find the same information from different sources. Okay, so there's a flow of information from somebody who's creating it in the laboratory to somebody who's using it later. So look at this chart here. The state-of-the-art research is usually found in journal articles, but that information filters down eventually to handbooks, encyclopedias, textbooks, and data compilations, which are known as tertiary literature. So I am going to stress the data compilations in this lecture because that's really the best way of finding chemical and thermodynamic data rather than going into original journal articles. Okay, so how many unique substances there are in the literature? So as of June 2017, as I am making this recording, there are just over 130 million unique substances that are reported in the literature from Chemical Abstract Service. You might be looking at this sometime in the future, so you can go to the Chemical Abstract Service website at www.cas.org, and you can see the current number of chemical substances that have been reported. Okay, and you can see on this chart here how over the years that the number of chemical substances have grown exponentially from 1965 to the present, over 50 years. Many chemical substances are just reported in the literature once, and they're really maybe only of interest to the person who first synthesizes them. My experience has been that at NJIT, at least, that the chemists and chemical engineers are interested in the established chemical substances that are quite known. This 100 millionth substance here that has quite of a complex structure and perhaps has only been in the literature once. Okay, so a data compilation, back in the old days they were available only in print, but now they're available electronically mostly. There are data compilations that made the transition from the print to the electronic, and there are data compilations that are digital natives that are only available in electronic format. You can't have a data compilation that's universal, that's get all compounds, but they're usually limited to the type of compound, be it organic or inorganic, or maybe a type of property, a thermodynamic, spectral, and so on. Okay, and a searcher may have to use several data compilations to find the desired information. It's very often trial and error. You don't find something in one place, you have to look in another. On the other hand, especially for common substances, there's a lot of redundancy, and you may find the information in several sources. And sometimes the values may conflict. There might be some experimental error involved. And okay, that no single data compilation can cover everything. So, keep that in mind. The characteristics of the various data compilations that we can use, limited by the number of substances. Some are maybe cover the most 50,000 or so well known type of compounds. Some might be only organic, sometimes only inorganic, sometimes volatile compounds, solvents, and so on. And selected properties only. There are some print and electronic databases that may only cover spectra. Some may only cover selected thermodynamic properties. And again, as I said before, they're available in electronic or print formats. And some of the data is critically evaluated. There might be an organization like NIST, which will evaluate the data that's found. And the values may differ. So here are a couple of readings. The first one is over 30 years old, but many of the points are still valid. The other one is a little bit more recent. 2001 is over 16 years ago already. But they're both on the research guide that I have here, researchguides.njit.edu/physical_properties. And I'm going to refer to that site later in the lecture. Okay, and here is an example of some print data compilations. The CRC Handbook of Chemistry and Physics. That's been around for over 100 years. I remember I used that back in high school. And a few others listed here with the call number where the source is physically located in the NJIT library. Some more printed data compilations in this page. Lange's handbook is very similar to the CRC handbook. The Merck Index has been around for a long time. We have it here in print. There's an electronic version, but we don't have it here at NJIT. It's for more compounds that are medicinally active. And then, of course, I know that many of you are chemical engineers. You're familiar with Perry's Chemical Engineer's Handbook. Okay, SciFinder. SciFinder is the electronic version of chemical abstracts back from 1907 to the present. It's a bibliographic database, and it contains links to full-text articles. I'm not going to emphasize that in this lecture here. You can search by chemical substance, reaction, research topic, author, or affiliation. So as far as this lecture is concerned, I'm going to show how it can be searched by chemical substance. And you will find some physical property data in SciFinder. And you must set up an account to search it. You only have to do this once in your time here at NJIT. Also, at this point, I want to bring up the concept of registry number. Every chemical substance is given a number when it comes into chemical abstract service. the indexers there will look at a paper and look at the substances, and if a substance is new, it will be assigned a registry number at this point. And when you search for a chemical substance, it may be actually easier to search on the registry number rather than the name. Okay, so again, there are chemical elements, compounds, polymers, biological sequences, and so on are given CAS registry numbers. And as we'll see a little later, they're used extensively in data compilations. So let's get on to SciFinder and do one exercise here, the density of cyclohexanone at 20 degrees centigrade. So let's get off this PowerPoint now for the time being. I'm going to go on to SciFinder. So to get in there, you go to the library homepage. It's library.njit.edu. Okay, that's the library homepage. It's the it's the entry point to the library. Most of the resources that we have today are available only electronically. So that's really our front door. So you click on databases here for SciFinder, submit. Okay, if you don't have an account, you must register here. I won't go through the steps at this point. I'll just show you what to do. Okay, and it just asks you for information, who you are, your email, and it will send you a link to your NJIT email account so it knows you're an NJIT person, and you would need to log into SciFinder with your username and password anytime that you need to use SciFinder. Okay, you only have to do that once when you're here at NJIT. So let's get into SciFinder now. I'll use my account and I'll show you how to search on for a substance. Okay, so it's my username, password, log in. I won't elaborate on SciFinder at this point. You can obviously search on it for references, research topic, author, company name, and so on. Chemical substances here. So I will just at this point in time just emphasize that. Okay, substance identifier. And I'm going to put in here cyclohexanone. Okay, search. Okay. Okay, so it gives me cyclohexanone here. Gives me the structure, the CAS registry number. We won't discuss finding references at this point. You can find out here the reactions. You can also find out who sells it. It's obviously a common chemical substance, which typical student would know here. You want the data on it. Click on the registry number. Okay, experimental properties, spectra, predicted properties, and so on. So you're looking for experimental properties here. Click here. I want the density here, and it gives you the densities at various temperatures. I was looking for 20 degrees centigrade, and it's there. It gives you the value. Most of the time when people are looking for chemical properties, they're only interested in the value. But there is a link here. If you want to see the original experiment, you can link here, and it will give you the reference where that experiment was done. Okay, you probably don't need to do that. Okay, so that's an example of how to search SciFinder to find a property. Certainly there are other resources that you can use to find the density of cyclohexanone. Okay, so let's sign out of SciFinder, return to our PowerPoint, and move on. Okay, Novel. Okay, Novel is a database that we pay for at NJIT. It's a database now of about 800 or so handbooks. So when you search Novel, you're searching over all these handbooks. There are certain ways you can search it that we're going to stress here. How to search Novel to find physical property data. Okay, and here's an example of some of the 800 handbooks in Novel that you can search. Electrochemical data, handbook for estimating physico-chemical properties of organic compounds. Let's look at the next slide. There's other handbooks here. Novel critical tables for the more established chemical substances, and so on. Searching in Novel. You can also look for textual information. There are interactive graphs and tables, and you obviously can access it from the NJIT library homepage. There's a link here for tutorials on how to search it. It's very easy to use. I think today that the publishers of the databases are making their services user-friendly so students can learn how to use it very easily. So what I'm going to do here is a class exercise using Novel to find the density of acetic acid. Okay, so let's get out of the PowerPoint again and go into the library home page. .edu. Okay, databases, search databases A to Z, K for Novel, Novel handbooks. Okay, takes a few seconds. Okay, so you can search on a textual term in the database using this search box, but we're searching for data. So what I'm going to say, material or substance name, I'm going to say acetic acid. Okay. Okay. So there's 292 handbooks within Novel which have information on acetic acid. We obviously don't want everything, so we're going to say here, find a property. We'll find specific gravity. Okay, so what we do here, we take this and we, whoops, okay, yeah, exists. Okay, there are 8 results. Okay, you drop and drag that into the box here. Okay, so we have here, this is a table here, and we'll click on interactive tables. It's all 8. Okay, so I'm going to view the table. Now one thing here, I searched on acetic acid, but it giving me other substances which have acetic acid in here, substituted ones, chloroacetic acid, trichloroacetic acid, ethyl dibromoacetate. We don't want those. We just want the simple acetic acid. And you see here, it gives you the CAS registry numbers. So what I'm going to do again, I'm going to search on that CAS registry number 64-19-7. And let's do the search again. Okay, search Novel, data search, 64 on the registry number, 19-7. So I'm giving an example here where it's easier to search on the registry number, so you only get that substance. And we're going to put here specific gravity. Again, drop and drag. Five results. And it will eliminate all those other ones. Click here. And it will give you the value here for acetic acid, molecular weight, freezing temperature. We wanted specific gravity, so that's over here. Okay, so that gives you that information here. Okay, 1.044 grams per cubic centimeter. Okay, so that's an example of how to search novel to find a simple chemical property. My suggestion is, when you're finished with this tutorial, is to look through novel. Do some searches on your own. Go through the tutorial so you can learn it. You're not going to learn it just on this video. Okay, so let's get out of here. Let's go back to our original PowerPoint. Look at some more sources here. Okay. The CRC Handbook of Chemistry and Physics. Okay, I would say that the essence of the information in here, maybe not all of it, is found in novel. Okay, but if you do want to look at the print version, we do have it in the library, and these are some of the physical properties that are in the CRC Handbook of Chemistry and Physics. Okay, so again, I guarantee you'll look at it, you'll find it. Okay, but I know students like yourself want everything online. Okay, we're going to look at my site here, researchguides.njit.edu/physical properties. Let's click here, and we're going to put this aside for the time being. Okay, but I will look at it later. Okay. 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 So again, there are a lot of these sources on that page that are very useful. I will not look at everything because with the exception of Novel and SciFinder, all the resources there are free on the web. Okay, I will discuss some of them here, but not all of them. Okay, so there's an index to physical, chemical, and other property data. Let's go back there now, and okay. So again, here's the PowerPoint here. You want to go back to it. So here is guides finding physical, chemical, and thermodynamic data. Let's take a look at the Vanderbilt University one. Okay, so if you have a physical property, as a lady who maintaining it. Let's say if you need heat of combustion, you don't know where to look, click on there, and it will give you a list of resources, both print and electronic, where you can find that information. Hopefully we have most of these here at the NJIT library, but it was done at Vanderbilt University, so everything there is at Vanderbilt. But hopefully you can find this useful if you do have a physical property and you don't know where to go to look for it. Okay? Back to the PowerPoint. Okay, the NIST Chemistry Webbook. NIST is a government agency, National Institutes for Standard and Technology. They used to be known NBS, National Bureau of Standards. I have shown this database to students for over 20 years. and I've been here my early days at NJIT, and it has not changed. These values don't change. You know, the IR spectra is the same. It won't change for a substance, and so on. So here's an example of some of the physical and thermodynamic and spectral data that's available through the NIST chemistry webbook. Okay, so let's look for gas phase thermodynamic data on bromoform. Okay, so I'm going to go back to my page here. Okay, go back here, get rid of this, and primary sources of physical property data. And I'm going to look here on, okay, NIST webbook. This is in alphabetical order here. Click here. So you see they use very simple HTML. It reminds me of the early days of the internet in the late 1990s. So you would click here. Okay, there's a where you can find, you can click on formula name, registry number. So I'm going to put name here. Okay, bromoform. And you can search for all this data here. I'm going to look for condensed phase thermodynamic data. Search. And it tells me the type of data that's available. Okay, here's delta HF, heat of formation of liquid, gives you the value there. And again, it also gives you the reference. Most likely you're only interested in the actual value, but if you want to read on how the experiment was done, it gives you a link to this, to the reference in 1982. So you can certainly, if you're interested, look up this paper. Most likely you're not. Okay, back to the PowerPoint. Okay. ChemSpider. ChemSpider's been around for a few years now. It's compiled by the Royal Society of Chemistry, which is the British counterpart of the American Chemical Society. So people, chemists all over the world, have given information on various chemical substances. So as I stated before, there are over 130 million chemical substances that have been reported. 59 million of them are in this ChemSpider database. So that's almost half of the substances that are known. So it's very easy to find. It's just www.chemspider.com. So let's take a look at ethylene glycol on that. Okay, so there is a link to it on the page here, but I'm just gonna, there's a link to ChemSpider. Maybe I may as well use that. There's also a slideshow on how to use it. ChemSpider. Okay, you just search here, ethylene glycol. Okay, the parent one. Okay, it gives you the very simple structure, the molecular formula, the mass, the different names, who sells it, spectra. So we wanted properties here, and okay, experimental gravity, and it actually gives you the links that these are a couple of chemical companies, and the chemical companies very often provide the data. So it provides you a link where that's found. So it gives you the density here of ethylene glycol that this company sells. So ChemSpider very often gives you a link, or sometimes it'll give you the actual data itself. So my suggestion to you is sometime after you finish with this presentation is to look at ChemSpider and do some searches yourself. So when there's a real live search that you need to do, you'll know how to do it. Okay, so that's an example of finding information through ChemSpider, which gives you a link to a resource. Alpha Azer is a chemical company. They sell small lots of chemicals, and they do provide information on substances. Okay, back to the PowerPoint. Okay, spectral database for organic compounds. Okay, this is a Japanese database. You can find some spectra in in this web book, but this is another source here. So again, there's a link to it. This is a Japanese organization. It is in English here. So I asked here to find the mass spectrum for anthracene. So we'll click on the link here. Okay, I agree to the disclaimer. So I'm looking for the compound name. I'm going to put anthracene here. Search. Okay, and again, it gives you the substituted anthracene, so you might want to search on the registry number. So it gives you, you click on here, anthracene, and then that's obviously the structure. And I think you wait a few seconds here, and it'll give you a link to the mass spec. Oh, here it is over here. Mass spec, and here's your mass spec of anthracene. Okay, so that's an example of how using this organic compound spectral database for organic compounds. Okay, all right. Okay, we did that. Material safety data sheets. Every organization, including NJIT, which uses chemicals in the workplace, has to maintain a material safety data sheet on every chemical substance. There's a link here. I'll leave it up to you if you want to try it. And these safety data sheets provide toxicological data, but also some physical property data on the substances. Other sources of property data. These, I believe, are all chemical substances. I think Sigma Aldrich is the most common one. I know chemists all over order small amounts of chemicals from the Sigma Aldrich catalog. I'll click on here, and they do provide chemical substances. You know, you want to look for a chemical substance here. Um, let's look for, cyclohexanone. Okay. Here you go. They do sell it here. And let's click on the link here. And it does give you some chemical properties. But they obviously want you to buy what they're selling. Okay. Okay, the Wikipedia. I know it's become very popular. I think it's been around since about 2004. I think, of course, anybody can write up a page in the Wikipedia. Anybody else can change it. So you just don't know the reliability of it. So obviously doesn't undergo a rigorous peer review process. But in recent years, it has become more reliable for finding physical property data. And I'm going to go back to my page here. And again, this is totally up to you if you want to look at it. Let's close out of here. Don't need this anymore. But under tutorial with narration using Wikipedia as a source of chemical information. This is about a 1 hour video where this Martin Walker of SUNY Potsdam argues that the Wikipedia is a very reliable source for information on substances. So here, let's go www.wikipedia.com. .org actually. I'm going to put in here a search on benzene. Benzene, of course, is very common. And you see here, it does give a lot of physical property data. Density, solubility, and so on. And one thing that I used to do, I used to have students look up properties in the Wikipedia and then find it in another resource and see if the values match. So I think that the Wikipedia, for I think pretty common chemical substances, is a good source of data, but don't rely on that completely. If you don't find something in the Wikipedia, try another resource. Okay. Okay, so again, there's mobile computing apps. Everybody has a cell phone these days, and there are apps on the cell phone they can use to find physical property data. So, to summarize, that in the physical chemical laboratory, you do experiments and you want to see if the values match. So that's why you need to use resources here that we have to find physical property data and see if it matches your experimental data. Okay, so original research is done in journals, but it's very hard to find physical property data in journal articles, so you hopefully can find it through data compilations. And there are over 130 million unique chemical substances, but probably here you're probably only interested in the most common. And also there's a lot of redundancy. You can find the same property data in several sources. Again, look at those indexes, but I think the most important thing is to use that research guide. Research guides at njit.edu/physical_properties, and familiarize yourself with some of the information there. Okay, so here who's I am. My name is Bruce Slutsky. I have here my email address, my phone number. If you feel you need assistance using any of the resources of the NJIT library, please feel free to contact me. So thank you very much for your attention, and I hope I'll hear from you in the future.